Hello everyone, welcome to another tutorial. Today we're going to solve one of the most commonly asked problem statement in companies like Amazon, Facebook, Uber with the help of LeetCode platform. LeetCode is one of the most commonly used platform by such companies to assess their candidates. So let's get started. The first statement is to sum. So first we'll try to understand and read the problem statement very carefully. So what they're saying is, given an array of integers, nums, and the integer target, return indices of two numbers such that they add up to target. So basically what they are saying is, we will be given an integer array nums and a target, and we have to return indices inside nums array, which will give us the addition to target. Okay, let's read. You may assume that each input would have exactly one solution, right? So what they are saying is, yeah, there will be only one possible solution to this target sum. So that's the assumption that we have to make, and you may not use the same element twice. You can return the answer in any order. Okay, so what they are saying is, you can return the answer in any order. So let's say if you find the target in nums, one at 0th position and one at the 5th position, then you can return the indices as 1 and 5 or 5 and 1. The order doesn't matter, which makes complete sense. So they have given an example. Input this and target is 9. So let's say like I think first and second is the index, which is 2 plus 7 adds up to 9. So 0 and 1 should be the answer. Yeah, perfect. Then 6 is the target and the input is this. Then the answer is 4 and 2, which is 1 and 2. Perfect. Okay, so constraints that 2. Okay, so what they have saying is, okay, so constraint is basically they're trying to say is the number length. The length of this integer array is going to be either 2, because of course we want target to be sum. So they're making sure it's 2. Minimum length is 2. Is greater than or equals to. So it's going to be somewhere between 2 to 10 raised to 4. So it's going to be a big array. So we have to consider the time complexity. We have to consider the time complexity of our solution as well. They have given a follow-up to our solution. Can you come up with an algorithm that is less than O(n) squared time complexity? Okay, so we have to come up with an algorithm or solutions whose time complexity is less than O(n) squared. Makes sense? Okay, so let's start. Okay, so let's start the solution. So let's return new int array with 0 element, just in case if we don't find anything. Okay, so what they have said is, we want to figure out a target indices from nums array whose sum is equals to target. So one of the most common solution to this is just iterate to nums with 2 for loop, one pointing to first element and other will travel all the way down to rest of the elements to see if the sum of 2 and rest of the element is equals to this target. If not, then we'll go back to 7 and rest of the elements, then 11 and then rest of the elements. So let's see brute force approach to solve this problem statement. So what we can do is we traverse through nums array and figure out and check the first element, for example this one, and for each element traverse through the number array, and for each element check rest of the array if the sum of the element these two is equals to target. And that's how you can figure out two indices. let's write down the code. This one is called brute force approach. For, let's take an integer I, which is going to start from 0. I is less than the nums dot length. We want to traverse the entire array. That's why we take a nums dot length and I plus plus. Now let's take the second array, for loop, which will give us int j is equals to I plus 1. Like I mentioned before, we are going to take second array, we're going to traverse rest of the array all the way down to the length and check if sum of these two equals to the target. So j is less than number dot length j plus plus. Here we go. Now we will check if nums I plus nums j is greater than target equal to target, then return new integer I and j. Okay, so this is the brute force approach. Now let's see if the solution is working. So now let's make this class static and this method also a static method. And okay, call them from the main method. So to sum, let's add the namespace dot to sum and give the examples, give the input array, which is, let's give the first one, which is this new int array comma target, which is 9. Target is 9. So the answer that we are expecting is output 0 and 1. So let's see what we get. Zero and 1. Perfect. Let's try another example. 3 to 4. And I think target is 6 here. Put, oops, we have an error. Index was outside the bounds of an array. Okay. J I plus 1 j, oh okay. So here the condition should be j should be less than. Okay, now it sounds good. Let me write down the output console.write and output second output is okay, let's see the output. Index 1 is 1 and 2 is 2. Okay, let's go back. 1 and 2. Let's see this example. 0 and 1 is expected. 6. 0 and 1. There we go. Now let's see what's the time complexity of this solution. So time complexity we calculate based on how many times array, that input, is being traversed. So if you see, we have for loop and inside we have for loop. So this is n times for this array, and this array again, inside that we are traversing to the same array, which makes it n into n, which is n square. And we have been asked to come up with an approach which is less than O(n) square complexity. So let's see how we can solve it in a more efficient way. Okay, so we have to get rid of this for loop inside this for loop. How can we do that? Let's take this example here. Two, 7, 11, 15. So let's say, and our target is 9. Okay, so in order to achieve O(n) square, first of all we have to get rid of this for loop inside this for loop, because the moment there comes another loop inside the same loop for the same array, it becomes O(n) square. So what we can do inside this one, okay, we want to get rid of this another array. Okay, let's see what we have. We have, like, inside this for loop we have ith element, let's say 2. We have target, what we need is 7. So 9 minus 2 is 7. There we go. So now we know the another number that we want to figure it out. We have search element, which is nums of I minus target. Now this is the element that we have to search. Now again, search operation inside the integer array. In order to do so, now in order to search this element inside this nums array, we will take a hash table. We can take dictionary with key as the value and value as an index, right? So let's take dictionary of integer, call it lookup, and complete this loop. We have to take another loop, let's take another loop. Int j is equals to 0, j is less than nums dot length j plus plus. For each element we are going to check if lookup dot contains that key is going to be basically a value, so which is nums of j. If it does not contains the key, we're going to add lookup that adds those values. So key is going to be the num of j comma j, just the index. Now we have the another element. Now we also have lookup data structure where we can actually search for this element. So what we have to do is, so let's take this part below this one, and we have search element. Now we just have to search for lookup dot contains the search element. If it does, then return new integer array with I comma lookup search element. This will give us the key of the searched element. Okay, so what we have done, basically we took a lookup to search for the other element. So we knew that, like, if we traverse this array just for once, then what we have is 2. What we are searching for is 9 minus 2, which is 7, and in order to find 7 we need to have a lookup data structure where the time complexity for the search is efficient. So time complexity for dictionary is basically O of 1, which is pretty cool. So what we did is we populated this data lookup collection, and then we search, we iterate through the loop, we iterate through the integer array, then we search the element that we're looking for. If that contains, this lookup contains that element, then we are returning the indices. Let's see the output. Oops, we have an issue. Let's see. Let's debug the code. Let's see the code once, what we have done. So we are adding value and their index in the lookup table. Perfect. Then we are iterating to the array again. Then we're searching for the num of I minus target. This one is giving us the negative number like 2 minus 9, which is 9 minus 7, and it's gonna give us minus 7, and that's why we didn't get the result. So what we're going to do is, as they said, the order, they have said in the problem statement that order of the return, you can return the answer in any order. So we can take the sum in any order too. Let's try to take absolute. So system dot math dot absolute of this, and 0 0, which is incorrect. Let's see what went wrong. Oh, if you see here, we have 3 and 3. It's returning the index of first item both times. So when we are searching for this search element, the other element, it's again picking up the first element because the sum is 6 and both item 3 and 3 both are same. So it's actually searching again for 3 for the searched item, and it's giving the index of first. We have to make sure that it's not again going for the same index. So lookup slash search item, this will give us the key value which is not equals to I. Let's see now. 0, 1 and 0. Perfect. Now let's take the another example to check if our answer is correct, which is I think we are searching for 6. It should be 1. Okay, now let's see if there is any way that we can improve our code further. So coming to the solution, if you see here, we have 2 for loop for nums array, and what we are doing in first array is we are adding values to look up dictionary. Then once the entire lookup is completed by the array size, then we are searching for the another element inside the same lookup. How can we avoid now the second for loop? Any guesses? Okay, so what can we do is, during we are adding things to lookup, we can also search for another element inside the same. Here we're gonna say number of j, whatever the number it is for the current iteration, minus target search element. Then we're gonna check if that lookup contains that search element, and lookup index is not equals to j. Then return j and lookup element. Now we don't need this one. Okay, so let's check our code. 2 and 1. Let's check for another example, which is 2, 3, 2, 7, 11, 15, and the lookup is for 9. It should come as 1 and 0. Perfect. Let's take the tricky example where we might get incorrect result. 1, 0. Perfect. So let's go back to our solution and see what we have done so far. In order to increase the efficiency of search inside num's array, we took dictionary of lookup. We traversed through each element inside the num's array and we added those values to lookup dictionary. Once the value is added to the lookup dictionary, we searched for the second element, which is current number minus target inside the lookup dictionary. If it is there and it's not the same as the current one, we returned the current index and the lookup index for the other element. That's all we have done. Now let's see the time complexity. Time complexity. We are iterating through this array only once, which makes it O of n. Plus we are doing the lookup in dictionary, which is nothing but O of 1, which makes it big O of n. So our time complexity is O of n, which is perfectly what they are looking for. It should be less than O n square, and which is O of n, which is quite good. So that's the time complexity of our algorithm. Let's copy this algorithm and paste it here in LeetCode and try to run the code. Okay, and there we go. Solution accepted. So that's our solution for today's problem. I hope this tutorial was helpful to you and you understand each and every step. I tried to break it down for you guys and I really hope you understood each and every step. If you have any queries or any question, you can ask me in the comment section below. For future videos, don't forget to subscribe and hit bell notification icon for more such videos, because I'm gonna come up with more problems to solve together. See you in the next video.